An automotive ignition system is divided into two electrical circuits, the primary and secondary circuits. The primary circuit carries low voltage. This circuit operates only in battery current and is controlled by the breaker points and the ignition switch. When the ignition key is turned on, a low voltage current from the battery flows through the primary windings of the ignition coil, through the breaker points and back to the battery. This current flows causes a magnetic field to form around the coil. The secondary circuit consists of secondary windings in the coil, the high tension lead between the distributor and the coil, commonly called as the coil wire, and external coil distributors, the distributor cap, the distributor rotor, the spark plug leads, and the spark plugs. As the engine rotates, the distributor shaft cam turns until the high point on the cam causes the breaker points to separate suddenly. Instantaneously, when the points open or separate, current flow stops through the primary windings of the ignition coil. This causes the magnetic field to collapse around the coil. The condenser absorbs the energy and prevents arcing between the points each time they open. This condenser also aids in the rapid collapse of the magnetic field. The line of flux in the magnetic field cut through the secondary windings of the ignition coil, creating a high voltage, high enough to jump the gaps between the rotor and the distributor cap terminals and the electrodes at the base of the spark plug. Assuming that the engine is properly timed, the spark reaches the air-fuel mixture in the cylinder and combustion begins. As the distributor continues to rotate, the electrical contact between the rotor and the distributor cap terminal is broken, stopping the secondary flow. At the same time, breaker points close to complete the primary circuit, allowing primary current to flow. The primary current will again create a magnetic field, and the cycle is repeated for the next cylinder in the firing order. This process takes place within a few milliseconds. In fact, it happens approximately 18,000 times per minute at 90 miles per hour.